Okay guys, this is the video lesson for 11-3 radical equations, and this is part 1 of a 2-part video. Alright, start out here by pausing the video and getting the definition down for a radical equation. Okay, so as it says, a radical equation is an equation that contains a radical. That's very simple. What that means about what you're going to need to do is what you'll see there in the bullet point, and what you need to do then is to square each side of the equation to eliminate the radical. Again, pause the video if you need to copy that down. Square each side of the equation to eliminate the radical. Alright, next definition, extraneous solutions. An extraneous solution is simply a solution to the original equation that does not work. Again, a solution to the original equation that does not work. So in other words, you're going to get some answers here that are not actually answers to the problem. And what that means for our bullet point in the next bullet point is that you are going to have to check all of your solutions. You must check all solutions, because you can do all of your work right and get an answer, but that answer is not an actual solution to the problem. It's an extraneous solution, meaning it's not a real answer. Okay, so there's kind of some definitions and some things to keep in mind. Pause the video to catch up if you need to. So what we're doing next now is I'm going to give you a little list over here of kind of the steps that you need to do in order to solve a radical equation. So the steps you need to do here to solve a radical equation, step 1, and pause the video if you need to get this written down. Step 1 is to isolate the radical sign that contains the variable, and I'm going to actually underline this because that's kind of important. Isolate is very important. The radical sign that contains the variable. Alright? We are only worried about the radical sign that contains the variable. So you're going to isolate the radical sign that contains the variable on one side of the equal sign. And that's really what isolating means anyhow. Getting the radical with the variable in it all by itself on one side of the equal sign. Alright, step 2 then, kind of like we've already mentioned, is to square both sides. After you isolated the radical, you will then square both sides. After you square both sides, you will simply have an equation that needs to be solved. And after you solve that equation, you need to then check your solution. So, pretty easy steps here. Really the main two are 1 and 2. Isolate the radical and square both sides. Again, pause the video if you need to catch up, because we're getting ready to do some examples. So, if you look at example 1 here, step 1 is to isolate the radical. So, is the radical that has the variable, which is this radical, obviously, square root of x is the square root that contains the variable, is it all by itself on one side of the equal sign? And yeah, it's all by itself on the left side of the equal sign. So step 1 is done for you. The variable is isolated. So what's step 2 then? Well, step 2 is to square both sides. So I'm going to square the left side and I'm going to square the right side. And we know that the square of a square root just cancels out, leaving you with just x, and 5 squared is 25. So that should be my answer, as long as 25 is not an extraneous solution. And again, you're always going to have to check here to make sure it's not an extraneous solution. So my check will be that I plug 25 into the square root, or plug 25 into x, which in this case is the square root. And does the square root of 25 equal 5? Yes, it does. The square root of 25 does equal 5, so yes, this checks out. Alright, so let's look at problem number 2. Is the variable with the, or is the radical with the variable? Well, here's the radical and here's the variable, the b and the square root. So is this all by itself on the left side of the equation? Yes. The only thing on the left side of the equation is underneath the radical. Or everything on the left side of the equation is underneath the radical. That would mean it's isolated. So you have the square root of 2b equals -8. So I am going to square both sides. The square root of 2b squared obviously is just 2b, and -8 squared is positive 64. So there's step 1 and 2, and now in this case step 3, we do still have to solve a little bit, right? We're going to divide by 2, and you're going to get, for your final answer, b equals 32. Alright, so there's your answer, but again, we have to check this. So to check this, I'm going to plug 32 into the equation. So I have square root of 2 times 32 equals -8. 2 times 32 is 64, so the square root of 64 equals -8. Wait a second. That doesn't sound good, because can the square root of something equal a negative number? I already know this is no. The square root of 64 is 8, and that does not equal -8. So this does not work. Means that this answer is not really the answer, and that your real answer is no solution. So the actual answer to number 2 is there is no solution. Now, let's think about that and think about why this is. If I look at this original problem again, is there any number that you can plug in here for b, and when you take 2 times that number, it's going to give you the square root of -8? No, that's never going to happen, right? You cannot take the square root of something and get a negative answer. So, that's one hint there, that if your square root equals a negative, there's going to be a problem. And in this case, it was, because you can't say the square root of 64 equals -8, because it just equals 8. Alright, so let's look at number 3. Step 1 is to isolate the radical, which in this case it is not isolated. Oh, sorry. You can see here on the left side, the 8a is underneath the radical, but then you have this extra +1 next to it. So I need to subtract 1 on both sides, giving me my radical all by itself. Square root of 8a equals 5 now. So now I have isolated the radical. I'm going to now square both sides. Square there, so I get 8a equals 25. And I am going to then solve by dividing by 8. So I'm going to say my final answer here is just a equals 25/8. I'm not going to change it into an improper fraction or mix, or it is an improper fraction. I'm not going to change it into a mixed number. It doesn't reduce. I'm just going to leave it as 25/8. If you said that that was 3 1/8, I'm fine with that, because 25/8 is 3 1/8. But remember, I'm going to have to check this anyhow. So I'm maybe checking it with 25/8 is going to be a little bit easier. So over here I'm going to do my check. And I'm going to say the square root of 8 times 25/8 plus 1 equals 6. Right? Well, this does make it easier, because look underneath your radical. 8 is 8 over 1. So these 8's cross cancel, so you end up with just the square root of 25 plus 1 equals 6. Square root of 25 is 5 plus 1 equals 6, and yes, 6 does equal 6. So yes, that does check out, which means yes, this is my right answer. 25/8 is the correct answer. Okay, so that's kind of the pretty simple part of this video, part 1. The next 3 problems will get a little bit more difficult, but again, follow the same steps. Step 1, isolate the radical. Step 2, square both sides. then solve and check your answer. Alright, so let's move on to the next three. Alright, here with number 4, brings up the point where I said in the steps that you need to isolate the radical that has the variable, that contains the variable, because look, in this problem there are two radicals. You have the square root of x minus 5 and you have the square root of 6. Well, it's impossible to get them both all by themselves. But again, we don't really care about the square root of 6 because that's not where the variable here is. Here's the variable, so it's this square root that I'm concerned about. I want to make sure that square root is all by itself on one side, and it is. It's all by itself here on the left side of the equation. So again, in this problem, I'm ready to go. The variable is isolated, so all I have to do is square both sides. So again, on the left side, squares and square roots cancel, so you're left with just x minus 5 equals, and then how do we square 2 root 6? Well, 2 root 6 squared, you could think of it as just 2 root 6 times another 2 root 6. 2 times 2 is 4. Root 6 times root 6 is root 36. Well, that's going to be 4 times 6, or 24. Or again, you could have just, squared the 2, squared the root 6. 4 times 6 is 24. Either way you really want to go about it. That's your answer, or that's what you get. You get x minus 5 equals 24. You then have to solve. Add 5 to both sides. You get x equals 29. And we got to check, make sure it's not an extraneous solution. So let's put our check step right here. And we got 29 goes in for x, so I'm going to have the square root of 29 minus 5 equals 2 root 6. Oh. Alright, so square 29 minus 5 is 24. Does that equal 2 root 6? So you're going to have to simplify a radical here. Square root of 24 is 2 times 12. Square root of 12 is 2 times 6. 6 is 2 times 3. So you're going to get a 2 that comes out, and you're left with root 6. And yes, 2 root 6 equals 2 root 6. So yes, this does check out. No problems with that answer. Answer of x equals 29 is correct. Alright, number 5. Again, start trying these on your own if you want to. The same steps are going to be used over and over and over again. So, step 1 here. Isolate the radical. I'll do that by adding 9 to both sides. So the only thing I have on the left side is the square root of, and it's the square root of 4x over 5 equals 12. Now, some of you might be thinking, simplify this square root of 4x over 5, rationalize the denominator. You might be thinking square root of 4 is a perfect square. You might be thinking these things, which is good because these are things we've learned. But remember, in this section, you're just solving. And in order to solve, all you have to do at this point is square both sides, and the radical's totally gone. So don't make more work for yourself. Just square both sides right now. Squares and square roots still cancel out, so you just get 4x over 5 equals 144. And now we got to solve this problem. This is just, again, review of the first couple chapters of algebra where you're solving equations. I'm going to multiply both sides by 5. So that's going to give me 4x equals 144 times 5 is 720. And then last step is to divide by 4. And we get x equals 180. So 180 is what I got. You got to check it though. So let's check here and see if 180 is right. So I'm going to put 180. So I'm going to have the square root of 4 times 180 all over 5 plus 9 equals 3. So 4 times 180 is 720. So I have the square root of 720 over 5 plus 9 equals 3. I'm going to simplify the square root of the 720 divided by 5. 720 divided by 5 is 144. So I have the square root of 144 plus 9 equals 3. Square root of 144 is 12. Oh, and I just realized I do not have a plus 9. This original problem said minus 9 way up here in the top. I didn't notice it because I wrote plus 9 below it and marked it out with red. So let's go back here and change this plus 9 in all of these problems to a minus 9. I thought this one was going to work out okay, and it looks like it does. So you finally down here have 12 minus 9 equals 3, and yes, 12 minus 9 does equal 3. So yes, this does check out, and yes, once again, x equals 180 is your final answer. Alright, last problem. This one's going to be a little bit more complicated because we are going to end up with x squared at some point, and you'll see why. First of all, let's look here and ask yourself, is this radical all by itself on the left side of the equation? Yep, it's the only thing. Everything on the left side is under the radical. So let's square both sides. Left side, squares and square roots cancel. I'm left with x squared plus 9x plus 14 equals. And then on the right side, remember, this is x plus 4 squared, which means x plus 4 times another x plus 4, which means you're going to have to FOIL. You're going to get x squared plus 4x plus another 4x plus 16. Middle terms, so I'm going to get x squared plus 8x plus 16. All right. So now again, after you've done that, you're back to just basic algebra. Combine like terms. I'm going to subtract my x squared on both sides. In this case, it cancels out in both cases. So now I just have 9x plus 14 equals 8x plus 16. Let's see, let's subtract the 8x. So I'm going to get 1x plus 14 equals 16. Then I'm going to subtract 14 on both sides. And I'm going to get a final answer here of x equals 2, it looks like. X equals 2. So, check step. Make sure this is a true answer. I have the square root of 2 squared plus 9 times 2 plus 14 equals 2 plus 4. Probably do some of this on your calculator. 2 squared is 4 plus 18 plus 14. So we're going to get the square root of 36 equals 2 plus 4 is 6. And does the square root of 36 equal 6? Sure does. Checks out. Final answer, x equals 2. So Again, hopefully not too difficult of a section, other than maybe adding that check step in to make sure the answer you got is an actual answer and that it's not a no solution problem. So that was video part 1. Go ahead and watch video part 2 next.